Hi, thanks for joining me today. I've got a fun problem from the Intermediate Maths Challenge, and this is like a competition maths problem set for students in year 9 to year 11, so that's around age 13 to 16. Anyway, we have a rectangle with integer side lengths divided into 4 smaller rectangles as shown. The perimeter of the largest and smaller of these smaller rectangles are 28 centimeters and 12 centimeters. So this rectangle here has perimeter 28 centimeters, and this small one in the top right corner has perimeter 12 centimeters. And we want to know which of the following could be a possible area of the original rectangle, so the whole rectangle. So we've got options of 90, 92, 94, 96, and 98 centimeters squared. And now the reason I'm doing this video is because it involves a pretty nice trick which I hadn't seen before with these sorts of problems, so quite nice. Anyway, if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to dive straight into a solution. Okay, so what I've done is I've taken this larger sub-rectangle and coloured its edges blue and the smaller one red. And we know that the red lines, or the 4 red lines, add up to 12 centimeters, and the 4 blue lines add up to 28 centimeters. Now the trick is I can move these lines, and obviously that doesn't change the total length. So I'm going to move that blue one there, this blue one here, this red one here, and this red one here. And what you'll see is now we get the perimeter of the whole rectangle. And so if I call this side length x and this side length y, we can confidently say that x plus y, or 2 times x plus y, which is the perimeter of the whole rectangle, is just the sum of the red lines plus the sum of the blue lines, which is 28 plus 12, and that's going to be 40. And so dividing both sides by 2, we get that x plus y is 20. Now this is really cool. We get x plus y is 20, and also we know from the question x and y are integers. So x and y are positive integers that sum to 20, and we want to know which one of these could be a possible area of the rectangle. Now we could just trial and error here with different values for x and y, and that actually wouldn't take too long. But a nice little thing we can do here is if we know that they sum up to 20, we know that x I can write as 10 plus k for some integer k, and y I can write as 10 minus k for some other integer k. For the same integer k, because obviously then they add up to 20. And now the beautiful thing about this is then the area, which is x times y, is just going to be 100 minus k squared by the difference of 2 squares. So we know that the total area of this rectangle is going to be 100 minus some square number. And now I can just look at these 5 options here and look at which one is 100 minus a square number, and that is 96, because obviously the difference between 100 and 96 is 4, and so that would be k is 2. And so we'd get something like x is 12 and y is 8. And therefore the answer to this problem is D. So a really nice problem with a really nice trick of kind of moving the sides of these smaller sub-rectangles to get the perimeter of the total rectangle. Good luck for anyone who's doing the IMC tomorrow or any point in the future, and I hope you have enjoyed this video. Thanks so much for watching. I'll catch you in the next one. Have a great day.